The wind arm is fitted on the CRP-5W. On the low speed side, use the end of the wind arm marked with an L. It has a graduated scale which corresponds to the speed arcs of the slide. For example, this is where we would normally mark a cross for 30 knots. Now if we rotate the wind arm, the 30 knot travels with it on the fixed scale. For example, there is 30 knots lined up with the 10-degree starboard drift line. Let's set on a wind velocity of 210 30 knots using the low speed side. So, don't need a pencil anymore, and I don't need a rubber anymore. All I need to do now is use the wind arm to set on a wind of 210 degrees. Using the low speed side, check that you are using the low speed end, and there is 30 knots. The inner scale may be rotated, and as long as the wind arm is lined up on where the wind is coming from, the reading will still show 210 30 knots. Let's try an example. Your heading is 116 degrees true, TAS 120 knots, wind velocity 260 40 knots. What is the track true and ground speed? There is 120 knots set underneath the centre dot. Now rotate the inner scale so that the given heading of 116 appears under the true heading index. Now put the wind on, which is coming from 260. Low speed side, low speed end. 40 knots is positioned above 9 degrees port. Heading is 116. You are blown from heading to track. With 9 degrees of port drift, you are blown 9 degrees port to a track of 107. And ground speed is 154 knots. Let's try another example. Heading is 227 degrees true, TAS 420 knots, track 234 degrees true. Ground speed is 385 knots. What is the wind velocity? Put the TAS of 420 knots in the centre using the high speed side. Now put the heading on by rotating the inner scale until 227 is under the true heading index. Track is 234, which is 7 degrees starboard. With a wind arm, you do not need to draw down the 7-degree drift line, but for illustrative purposes, in this example, I will. The 385 speed arc is that one there. You will see that when I turn the wind arm onto the intersection between the 7-degree port drift line and the 385 speed arc, the wind is already shown as 60 knots from a direction of 177 degrees. This is the practical example that you use in everyday flight. TAS is 170 knots, so use the low speed side. Move the slide so that 170 knots appears underneath the central dot. Rotate the inner scale to a required track of 036. Now put the wind on, which is coming from 083. Low speed side, low speed end. Count down 35 knots, which is positioned over 10 degrees port drift. Now we need to drift balance. Rotate the required track of 036 to 10 degrees port. Check to make sure the wind arm has not moved, and check what it reads. It now shows 9 degrees port. Both readings of drift are the same, 9 degrees in this case, so drift balancing is complete. True heading is 045. And ground speed is 144 knots. That's the beauty of a wind arm. Let's check the wind velocity at a turning point using an example. TAS is 220 knots, inbound heading is 195 degrees true, with drift of 6 degrees, starboard. Outbound heading is 278 degrees true, with drift of 4 degrees port. What is the wind velocity? Using the low speed side with 220 knots TAS underneath the central dot, rotate the inner scale so that the inbound heading of 195 appears under the true heading index. Now this is the time when I actually have to draw down on these ones. Draw down the 6 degree starboard drift line. Then rotate the inner scale so that the outbound heading of 278 appears under the true heading index. Draw down the 4 degree port drift line. Now it's low speed side, so turn the wind arm around to see where the low speed end hits the cross. Wind direction from 066. And wind speed of 32 knots. Headwind and crosswind components on a runway are solved on the squared section at the bottom of the slide. For example, calculate headwind and crosswind components on runway 19 with a surface wind of 150, 25 knots. Move the inner scale so that the runway direction of 190 degrees magnetic is positioned under the true heading index. Line up the wind of 150. It's a 25 knot wind, so we have a headwind component of 20 knots and a crosswind component from left to right of about 17 knots. Headwind and crosswind components may be calculated using an electronic calculator using the following formulae. Crosswind component equals sine of the wind angle multiplied by wind speed. The wind angle is 190 minus 150 equaling 40. Sine of 40 multiplied by 25 is 16 knots. Headwind component equals cosine of the wind angle multiplied by wind speed. Cosine of 40 multiplied by 25 is 19 knots.